Assalamualaikum students, hope you're doing good. Please mark your attendance in the chat box. So student, as we have finished all the exercise questions, now we will do the mini exercise. Open page number 182 of your book. Students, open page number 182 of your book. We will do mini exercise today. Uh, Tehmoor Ahmed, kindly open your camera. Okay. So the first question in mini exercise is how specific heat differs from heat capacity. So all of you know that what is heat capacity and what is specific heat, right? So what we have to do, we have to write the difference over here. For that, you have to make the column. So first of all, you have to make the column. In one column, you have to give the heading of specific heat. In the other column, you have to give the heading of heat capacity, right? Then the first point will be the definition. So specific heat is basically the specific heat of a substance is the amount of heat required to raise the temperature of 1 kg mass of that substance through 1 Kelvin. So whenever the temperature rise in 1 kg of mass, that is 1 Kelvin, we can say that the body has specific heat. But if the overall mass is increasing, heat is increases in a mass of 1 Kelvin, then we can say that it is a heat capacity. So this is a major difference between both, right? So then you have to write the definition as well in heat capacity. Heat capacity is the quantity of thermal energy absorbed by it for 1 Kelvin increase in its temperature. Then in second point, you have to write the formula for each quantity. For specific heat, the relation is given by C is equals to delta Q by MC. And for heat capacity is equals to MC. The third point is you have to write the unit of specific heat, that is joule per kg per Kelvin. How? This delta Q is the unit joule, mass is measured in kg, and um, so hold us, students, hold 1 minute. And this, sorry, this is delta T, right? This is delta T. So temperature is measured in Kelvin, right? So the units will be joule per kg per Kelvin. Student, you have to make correction over here. The unit for specific heat is C is equals to delta Q by M delta T, right? So in this way, we can write the units for specific heat, joule per kg per Kelvin. For specific heat capacity, mass is measured in kg, and as we have to write the unit of heat capacity, that is equals to joule per Kelvin, right? So joule is for heat and Kelvin is for temperature, right? So we can write it as delta Q by T over here, right? Delta Q by delta T. This is equals to heat capacity, right? You have to write over here instead of this, right? So this is the unit for heat capacity and this is the unit for joule per kg per Kelvin. So you have to write all three differences in the first question, because in the question they have asked that how they are different from each other, right? Then see the second question. Give two uses of cooling effect by evaporation, right? So you have to give the only two uses. You can also write your own uses which you are observing in your daily life. So the first one is put a little sprit on your hand and wave around. The sprit evaporates rapidly and our hand feels cooler. So this is the one use. The second one is, especially in villages, people often sprinkle water on the ground in front of their homes during the hot summers. So these are the two uses of cooling effect by that are caused by the evaporation, right? So the third question is how evaporation differ from vaporization. Again, the word use is used differ. So again, you have to write the difference between evaporation and vaporization, right? For that, you have to again make a column between two quantities. One is evaporation and other is vaporization. First of all, you give that tell that what is evaporation. It is a process by which liquids changes to its vapor to at a temperature below its boiling point. And then vaporization is, it is a process by which liquid changes to its vapor at its boiling point, right? So for evaporation, there is no need to be concerned about boiling point. It can be done at any temperature. But in case of evaporization, it can be only performed at a boiling point of that substance, right? Then at it take places at all temperatures, and it take places only fixed temperature, that is its boiling point temperature. So normally you that the evaporations take can taking place at all temperature, but vaporization, it has a specific temperature, and that is basically the boiling point of that substance, right? So this is also a big difference between them. The third point is temperature may changes during evaporation. Temperature during vaporization does not change. Obviously, it whenever the evaporation take place, or obviously it will depend upon your surrounding as well, that what kind of temperature is in your presence, right? So if it is a very hot season, then evaporation can be take place very rapidly. But if there's a winter, so the process will be slow down. So it can be, but the evaporation can be slow, can be fast, but temperature can be vary. But in case of vaporization, temperature will be its boiling point, right? Temperature will be not changing, right? Then evaporation is a slow and silent process, whereas vaporization is a fast and violent process, right? The fifth point is evaporation take place only at a surface of a liquid. It take places over the entire mass of the liquid. That point we have already discussed during the lecture, that evaporation is only take place on the surface of a liquid, but vaporization is take place through the entire mass of the liquid. So these are the five differences for evaporation and vaporization. You have to write all these differences in your notebook. So now I have to discuss about second monthly test paper pattern with you. So first of all, make sure that the monthly test consists of 30 marks. Mostly the paper is objective type, right? Because you have to do it online, and there's no enough time that you can do calculation or write the long answers. So for your convenient, uh, the first part is consist of MCQs, that is about 20 marks, right? And each MCQs carries 1 mark. right? So, and the question answers that are carrying the 10 marks and the five question for each marks. And the question answers are very short. So if you open the page number of your book 169, you have to go through from the first topic is 8.1, that is temperature and heat. So you have to know what is temperature. All of you know that temperature is basically the degree of hotness and coldness of a body, right? So you have to know, go through from all definitions. What is thermal contact, what is thermal equilibrium, what is heat, the side information given on page number 169, it is also very important. So you have to go through from all these do you know information. So in this way you can easily solve the MCQs, right? Because MCQs, they are not only coming from exercise. MCQs that are mentioned in exercise are also included, but you also have to go through from all the topics from the book as well, right? So these are the topics, the temperature and heat. Then the second one is thermometer. You know what is thermometer? Just go through from the mini exercise on page number 170, that which of the following substance, you can open page number 170. Which of the following substance has greater average kinetic energy of its molecule at 10 degrees centigrade? The four options are given to you. One option A is steel, B is copper, C is water, and D is mercury. And the right answer is water. Obviously, you know the liquid has more kinetic energy as compared to the solid substances, right? Then you have to also go through from this mini exercise. Then on page number 170, there are the properties that are given for thermometric liquids, right? So you have to know that what are the properties of thermometric liquids, that why we are using these thermometric liquid in our thermometer, right? These are the 7 properties mentioned on page number 170. So you also have to recap them. Then open page number 171. If you see the figure 8.4, there's a construction of thermometers given to you. Then you also have to see in detail that how we can construct the thermometers, right? What are the lower fixed point and upper fixed points? You have know that for if you measure in Celsius scale, the lower fixed point is 0 degree centigrade and the upper fixed point is 100 degree centigrade, right? Then if you consider Fahrenheit scale, the lower fixed point is 32 degrees centigrade and the upper fixed point is 212 degrees centigrade. And for Kelvin scale, the lower fixed point is 273 and the upper fixed point is 373. So these are the key points that you have to remember to solve the MCQs, right? Then you must know that what is the absolute zero. So the absolute zero is equals to minus 270 degrees centigrade, right? Then if you see the problem on page number 8.1, 8.2 and 8.3, these are the very simple problems, examples. You have to go through them as well, right? Because you can solve them easily, and make sure that you have to keep a calculator with you. So if there are any problems that comes in MCQs, and you just have to solve it and then just mark the right option, right? And for that calculation you have to keep one sheet with you for your A's, right? So these are the examples. These are very important. Then if you see page 173, there is do you know? A clinical thermometer is used to measure the temperature of the human body. It has a narrow range from 35 degrees centigrade to 42 degrees centigrade. It has a constriction that prevents the mercury to return. Thus, its reading does not change until reset. So the question can become that why the mercury is not going back to its, what make the mercury to be stick on that specific value that is measured, right? So the answer is written over in the box, do you know? So you can then open page number 174. Then you must know that see the table 8.1. There are different substances which are and their specific heat is also given over there. So you also have to go through from them. Then the 8.3, you must know what is specific heat capacity, what is the importance of large specific heat capacity, right? Then you must see example 8.5, right? Then open page number 176. The heat capacity is right over here. Then the side information, do you know? You also have to read it for your monthly test. Then come on page number 177. The topic is 8.4, that is change of states, right? So you, if you see figure 8.8, there is a solid that is given to you, and when you do melt it, it will be converted into liquid. So what happening over there, basically the thermal energy is observing, it is observing the thermal energy when the solid is ice is absorbing the thermal energy, it will be converted into a liquid, and when it will further absorbing the thermal energy, it will be converted into a gaseous form. So you must know what is the process going on, right? Then if you again if you go in a reverse process, that is from gas to liquid, the process is known as condensation. And what happened over here, thermal energy is basically releasing in this case, right? So these are the very important things regarding your paper, right? Then you must go through from activity 8.1, right? In this activity, you have to know that from minus 30 degrees centigrade to 0 degrees centigrade, the ice is converting into liquid. But then you see that from a certain temperature, you see the straight line from T1 to T2. If you see the figure 8.9, right, the temperature is not changing. So what happening over here, basically this is a latent heat of fusion. So you know that this is a latent heat of fusion, because in this case the heat is absorbing to change the state of a substance rather than increase the temperature. So you know that these type of questions can become in a reasoning question, that why the temperature is not increasing when it is when the ice is converting from converted into a water, right? So you must know the reason that behind it, right? So these are the reasoning questions, conceptual question that will be coming in your MCQ space, right? Then you, if you open page number 178, the topic 8.5 is latent heat of fusion. You must know what is latent heat of fusion, and what is the fusion point. And fusion point is also known as a melting point, right? Because in this process, we are converting ice into water. Then you must know what is freezing point, what is the formula for latent heat of fusion, what is the unit for latent heat of fusion. Again, this experiment 8.1 is same like activity 8.1, but it will be in detail, right? So you have to go through um, it as well. If you see page number 179, you have to see the graph, and in this way you can understand that what is happening over here, right? So you have to see all these calculations. You must know what is the value of latent heat of fusion of ice, right? That is 3.36 into 10 raised to power 5 joule per kg, right? So then if you open page number 8.6, it is latent heat of vaporization, right? So you must know that what is the definition of latent heat of fusion, what is the purpose of latent heat of fusion, and what is the formula that we are using in latent heat of fusion. And then you must know that what are the unit of latent heat of vaporization, right? So, and the most important is what is the value of latent heat of vaporization, and that is we have also calculated, and it is also given in your book, that is 2.26 into 2.26 into 10 raised to power 6 joule, right? So you know that the heat is always measured in joules, right? So that's are all very important things that you have to keep in your mind. Then if you see table 8.2, there's different melting points, boiling point, and latent heat of fusions are given to you. So you just no need to memorize them, but you just have to go through from them, right? For your better understanding. So now, if you see, then again, you have to go through from experiment 8.2. Again, you have to see the calculations that are done over here regarding latent heat of vaporization. For what is the purpose of this graph? Basically you are calculating the latent heat of vaporization, so you have to see the all the parameters that are using over here and then the calculations. And then you know that if we just changing the changing temperature, we can just write 100 degrees centigrade into 100 Kelvin, right? So what is the rate of heat absorbing? That is equals to delta Q by T naught, right? So these are all the things that you have to go through for your MCQs base monthly test. Then the second next topic 8.7 is the evaporation. Then you must know what is the definition of evaporation. Evaporation is basically the changing of liquid into heats from the surface of the liquid, right, without heating it. So here the two points that I mentioned over here, that the first thing for evaporation that you have to that it is only take place on the surface of a liquid. Second is without heating, right? So then you have to know that you also see these question of mini exercise that we have done today, right? Then you must know that what are the roles of evaporations that are taking place in our daily life, and how do you feel, why do you feel the cooling effect after evaporation? Because when the evaporation take place on the surface, obviously the kinetic energy of molecules that are active, they're basically active on the surface. So that's why when they just evaporate, it will they left behind with a cooling effect. So this is all the question of exercise that you have done. Then you have to know that the different factors that are affecting on evaporation depends on evaporations are temperature, surface area, wind, nature of liquid, right? Then also you have to see this coolings in refrigerators, that how the cooling is taking place in refrigerators. And we were using the CFC, chlorofluorochloride gas, but now we are using these chlorofluoro gas. They are basically replaced by freon gas and ammonia because they are not harmful for our environment, right? So you also have to go through from each and every side information, every box that are given in your unit 8, right? Then the next topic is thermal expansion. So you must know what is thermal expansion. You have to know that what is how thermal expansion take place in solids, how thermal expansion take place in liquids, and what are the two thermal further categories of thermal expansion that in one way you are dealing with linear thermal expansion in solids. So what is the formula for linear thermal expansion in case of solids? So this is a formula written over here. And what is the coefficient of linear thermal expansion for substance? You must know that is alpha, that is equals to change in length divided by original length into change into time, sorry, temperature, right? Then if you have you also have to go through from table 8.3, that is coefficient of linear thermal expansion alpha of some common solid. So you just go through from them. So just see the above and the below coefficients, right? Then you have to see example 8.6, right? So these are the simple MCQs. These simple examples that can become in your MCQ. So just you have to put the values and calculate the answer, right? Then you have the volume thermal expansion. You must know that what is volume thermal expansion, and in which substances the volume expansion take place, what is the formula for volume thermal expansion, what is the coefficient that is used for volume thermal expansion, and that is beta is equals to delta V by V naught delta T. And the very important point over here is the coefficient of linear expansion and volume expansions are related by equation beta is equals to 3 times alpha, because alpha is a linear coefficient and beta is a volumetric coefficient. Obviously volume has three sizes: length, breadth into height. So it will be equal to 3 times linear coefficient to be equal to volume coefficient, right? So this equation is also very important, that is beta is equals to 3 alpha, you know that, right? Then if you see example 8.7, what is going on over here, that you have to find out the volume of brass at 100 degrees centigrade, whose side is 10 centimeter at 10 degrees centigrade. So you know that this is a volume, so each side must be equal, that length, breadth and height are same. So this is the case of volume, right? So you know these little concept as well. Then the consequences of thermal expansion. that what are the consequences taking place during the thermal expansions, right? These are the uh, in the railway tracks we have just placed some spaces to avoid the any accident, right? These are the spaces given over here, right? So why we left the gap in bridges? Because of the thermal expansion that they are expand during the daytime, because there's sufficient heat. So that's why we just placed some gap over here in case of a s- s- iron and steel bridges, right? Because they have the property to expand. Then you have to see the different applications of thermal expansions, that how in where in a daily life we are using the thermal expansion. If you see, the most common example is thermometer. Then you can use the thermal use the you put the cold water into the hot water to lose the cap of a bottle, right? So this is all the applications of thermal expansion. Then we have discussed the hot driver inserted after hammering, showing figure A and B, right? So these are all the applications. So you have to go through them as well, right? Then the bimetal strip, you know that what is the bimetal strip? It is basically two metals are used in these strips, and mostly we use the brass and iron metals, right? So what is the property? What is happening if we heat these bimetals? So what is the function basically taken place by it? So you have to go through from it. Then you have to see the figure 8.20. Then you must know that where we are using the biometal strip that are using in thermostat switches, they are using in the electric iron and heater coil, right? So that we are using the to control the temperature by using the bimetal strip. Then you know about the thermal expansion of liquid. Then there is a very important side information that is given in the side of thermal expansion of liquid, that why there's anomalous expansions of water, because below 40 degrees 4 degrees centigrade to 0 degree centigrade, the water has abnormal property, it will be start expanding. So you must know that, right? Then the in thermal expansion of liquids, we have the two: apparent volume expansion and the real volume expansion, and we have already discussed the process that is involved over here, so you have to go through it as well. Then you must know that what is the formula for how do we can calculate the real expansion in case of liquid, that is beta r is equals to beta a plus beta g, right? So this is all about. So you have to go from your chapter as well. Then you have to see the MCQs that are given in your exercise as well. So these are also included in your exams. Then 8 point, these are all the questions answers that you have to just recap and go through from it, right? Then all the problems, you just see the problems, because if the problems or examples will become, there will be only a short part that you can easily be solved. So if you have any question, you can ask me regarding paper. Yes, students, if you have any question, you can ask me. Otherwise, I have to end the meeting. Okay, I will open the slide. These are the questions you have to do. The one is how specific heat differs from heat capacity. You have to write the difference. I will upload this lecture on Word Classroom as well, so you can do from here. And the second question is give two uses of cooling effect of evaporation. And the third one is how evaporation differs from vaporization. So that we have done today, and just discuss the paper pattern and topics, right? If you have no question, then I have to end the meeting, right? You just have to go through from them, right? Tables, just the upper and lower values, but you have to remember all the side information for your paper. And yes, you have to write the MCQ, sorry, mini exercise in the notebook today, right?